Project 2.4, The Binary Game by Atticus Siblady. Contrasting the only hardware aspect of the past three projects, this project implements the addition of code using an Arduino Nano. This project aims to demonstrate how using code through an Arduino Nano and other critical components, like an 8-position rocker switch bank, it is possible to assemble the state of the 8 switches as an 8-bit binary value and display them on a bar graph. In the code utilized, some of the key concepts that led to the creation of the circuit was the addition to bitwise operators and bit shifting. Bitwise operators were vital in creating the project as they functioned similarly to the regular operators used in previous projects. The key bitwise operator that was used within this was the use of an OR bitwise operator. What this operator can do is to act similar to the 4071 logic IC and is represented by a vertical line. The truth table for an OR gate is as follows. For example, if you had two different binary values such as 1001010 or 74 and 0101001 or 41, and you wanted to OR the two values together, the outcome would be 1101011. Another key aspect in this project is bit shifting. When counting in binary is counted using ones and zeros. As you move left through the digits, each placement is multiplied by 2 to represent a new number. This means as you multiply the original number by 2 to the n power. Bit shifting is where the number is multiplied by 2 by the number of bits you want to shift the number by. For example, if the number 10 would be bit shifted 3 times, it would change into 10000. We can actually view this in code as it is represented through the use of 2 inverted chevrons. As stated before, the circuit's original purpose is to display on a bar graph when you press one of the 8 switches. How does my code work so that it actually gets displayed? Well, first, we define the name of each pin that we're going to be using. The reason that data, clock, and latch start with an A before the number is because they're on the analog side of the Arduino Nano. I put these on the analog pin so it's easier than putting every wire on the same side of the chip. After defining each pin, you need to define if that specific pin is going to be an output or an input. Every pin coming from the switches are going to be input, as the 3 pins that are output to the bar graph are going to be an output pin. We put these in the setup section of our code and not the loop section, as this causes the code to not repeat this section, while the loop section repeats it forever unless a condition is set. Next, I then created a parameter called assembled. What does this mean? This means that I can set certain things or numbers as assembled, so I do not need to write it out. It's a way to write things in a shorter fashion. Following this, I set assembled to 0 so that the code can loop, and without it, the code would not work. Quickly, what digital read is that it will read the state of the switch or input as either high or low. You need this because the circuit does not automatically read whether the input is high or low. Now, the interesting portion of the following step is that I set assembled equal to the outcome of the switch. With each switch moving to the right, I bit shifted it n number of times, meaning the first switch would be equal to 1, the second 2, the third, the fourth, etc. 2 to the n amount of times. The last 3 steps I took was to display it on the bar graph. Recalling Project 2.3, the D flip-flop, the latch must be set low to shift something onto the bar graph, and setting it high will show it. That's why I have these 3 commands. Lastly, I printed assembled out on the serial monitor so you can view the state of the switches on Arduino. Thank you for taking the time to watch this video. I hope you learned something new. Thank you.